Hello guys, in this video we will protect our TCP tunnel with AES encryption. Now AES encryption can operate in different modes. The mode that we will be using it's called cipher block chaining or CBC. In CBC mode, the plaintext data that we want to encrypt will be divided into blocks where each block has a size of 16 bytes. Now each block of plaintext is XORed with the previous ciphertext before being encrypted. So as you can see here, the plaintext data is XORed with the previous output of the cipher from the previous block. And to make sure that each message is unique, there is an additional random input which is called initialization vector, and that initialization vector must be used in the first block just to randomize the encryption. Now in block ciphering, if the message size was less than 16 bytes, then we must add an additional padding so we can reach to 16 byte size of data. Now on the receiver side, we need to reverse the steps by decrypting the message and then removing any additional padding. Now I know that this is very brief about AES CBC, but keep in mind that there are entire books on AES and cryptography, and I just want to cover the parameters that we need to know before start coding. Okay, so let's get started with the practical part, and as usual we're gonna start with installing the necessary library. And for the crypto, I'm gonna use a Python library called crypto do me x. So I'm gonna type pip, then install, then pycrypto do me x. Okay, and we need to install that on the Kali side as well, and I will be using pip3 instead of pip. And let's type pycrypto do me x. And the reason that I'm using pip3 instead of pip, because I do have multiple versions of Python on the Kali Linux, and this specific library by default will be installed in Python 2.7 path. Now when you use pip3, it's gonna be installed on Python 3 path. Okay, so right now we will start with a simple AES program, and then we will integrate this AES with our previous TCP tunneling. So we will start with importing the AES class as well as the padding class. Then we will define the AES key as well as the initialization vector. The key size is going to be 32, which means that we are implementing AES 256, and the size of the initialization vector must match the block size, which is 16 bytes. Now here, just as an example, the key and the initialization vector, I made them as a letter H. But please keep in mind that you need to change this to a more complex key in the real world scenario. Now next step, we create an AES object and we pass the AES key as well as the mode, which is CBC, as well as the initialization vector. Next, as an example, we just specify the message that we want to encrypt as a hello message or hello string. Then we pass the message that we want to encrypt to the pad function, and the pad function will append any extra data to make sure that the size of the message is 16 bytes or multiplied of 16 bytes. After we append the padding, we can now call the encrypt function and pass the padded message. Now let me just clear the screen and let me just comment these entire lines, and let me just close this as well. So right now let's try and run the code. So here, as you can see, this is the encrypted message. Okay, so let me just go back to our code and let me just remove the comments. So the decryption is literally the reverse operation. I created a decipher object with the same AES mode, key, and initialization vector. Then I pass the encrypted message to the decrypt function, and the final step is to remove any additional padding that we have added. And finally, we're gonna print out the decrypted message. So let's run the code one more time. and if everything was working fine, we should be able to get the message back in a clear text. So let me just do save, and fair enough, we can see the message in a clear text. Now notice here, no matter what the size of the plain text message, the padding function will take care of splitting the text into blocks where each block is a 16 byte. So as a test, let me try to increase the size of the message, and I'm gonna multiply this with 57, for example. Let me just save and run. And as you can see, we got 57 of hello string output. Okay, right now let's see how we could integrate our encryption function to our reverse TCP shell. Keep in mind that, as we said earlier, AES is symmetric encryption, so the same key as well as the same initialization vector should be matching on both sides. Also, on both sides, I have added a new function to do encrypt as well as decrypt. So this is how it's gonna work. On both sides, before sending anything, we will pass the message in a clear text to the encrypt function, and the returned output of that encryption function is going to be the cipher text. Once we have the cipher text, we can right now send this cipher out of the TCP socket. And before we get any message, we need to pass that message to the decrypt function. So we pass that cipher to the decrypt function, and then that cipher function is going to return back a decrypted message or clear text message where we can process. And the same thing is going to be happening on both sides. Okay, so let me clean the screen and scroll down a little bit so we can have a quick overview on the entire code. So the shell is going to be starting on the Kali side, and as we said, before we send any command, we need to pass that command to the encrypt function, and then we can send that command. And the other way around, once we got anything from the target side, we need to pass it to the decrypt function. And the same thing is going to be happening on the target side. We need to decrypt the command first, execute it, and then send the execution back after we pass it to the encrypt function. Let me try to run these scripts and have a quick look. Okay, so before we get started and running the script, I have just started Wireshark, and I am filtering on IP address of our target as well as a TCP source port of 8080. So let's go ahead and try to run this script right now, and then we can verify using Wireshark that all the traffic is being encrypted. So let me, as usual, start from the target side, and we get our shell, and let me just minimize this a little bit so we can see the Wireshark window as well as the shell here. So let's start with a normal command like cd, ipconfig, etc. And then we got our packets here. Now, to quickly verify, what we can do is to use a Wireshark feature, which is the TCP follow. If we do here follow TCP stream, here's the output. You can see all the output is being encrypted using AES, and this is exactly what people interrupting the message in the middle can see our traffic. So this traffic is going to be passing through firewalls, IPS, etc. These devices exactly see the traffic as cipher, as you can see it here. Okay guys, I hope that this lecture has been informative for you, and thanks for watching.